Hi, this video is to cover the last two problems on the test review that you have for tomorrow's test. So for number 12, you're given a quartic function. Remember, it's called a quartic function because it's degree 4. So the first thing I've done is type it into my calculator. Now, what you're going to have to make sure you do is locate all critical points. So remember that your critical points include your zeros of your function, meaning your x-intercepts, as well as any max and min values. Okay? So we're going to type it in our calculator and graph it. And remember that because we have a negative leading coefficient, it actually opens down. Problem is, it looks like we can't locate our max and mins right now with our window being what they are. So note that on your test review paper, I've got negative 20 up to 20 on your y. So right here, negative 20 up to 20. So that should fit. Let's go ahead to window, and then you want to increase your y max to 20 and decrease your y min to negative 20. Good. Now we can see all of our critical points. So the first thing I'm going to do is locate all zeros. So recall, to do this, we go to y equals and put 2 in at y2. Now I'm going to hit my left arrow to move my cursor over to the left, hitting enter to make it bold so we can actually see that horizontal line on our screen. And there it is. So you can tell that we have 1, 2, 3, 4 zeros to find. So this method of putting in 0 and finding intersection is really quick and easy. So to find our points of intersection, our zeros here, we're going to hit second trace. And while 0 is one way to find them, especially if you have multiple points, like I said, finding the intersection is a lot easier. So second trace 5. And you can see our cursors right here on our y-intercept. So I'm going to start on the left by hitting my left arrow, move my little cursor dude over here and hitting enter, enter, enter. And you can see we've got a point of negative 3.9. So I'm going to come over here. And to locate that point, this is negative 10, so halfway would be negative 5. So it's right about there. And I'm going to write the order pair negative 3.90. Okay, so that's our first one. Continue, second trace 5. Move our cursor over here. Enter, enter, enter. You don't have to be right on it. As long as you're close, you're good. Negative 2.2. Remember, we want you to round to the tenths place. So you need to look at the hundredths place. And if it is 5 or greater, round the tenths place up. So this will be negative 2.20. So I'm going to do right about there. And put in negative 2.20. Do it again. Second trace 5. Enter, enter, enter. 0.2 and 0. So just past the origin. Do not assume it's at the origin. 0.2, 0. And one more time. Second trace 5. Move it over here to the right. Enter, enter, enter. 1.9 and 0. So right about there. 1.90. Alright, so I know that it goes down forever on this side and down forever on this side. Our job is to figure out our max and mins next. So I'm going to start here, and if you notice, you've actually got 2 max points. You've got one here, and your 1 min. So I'm going to start on the left, second trace maximum, so you can either press 4 or scroll down to 4 and hit enter. Now what we have to remember is we do have to set a left bound and right bound for this point. Do not go directly to that point and hit enter, enter, enter like we did for the intersection. This is a different set of instructions. So hit your left arrow to move your cursor over. So it's right there, but you cannot just copy down that value. You have to go to the left. I usually go to the left, make sure it drops down, and I hit enter. Then make sure I'm on the right side. So as soon as it drops, I know I'm good. Enter. And then it says guess, so hit enter again. So you're going to mark left bound, hit enter, right bound, hit enter, and then enter one more time. And you can see it says maximum. It should say maximum, negative 3.2 and 13. So I'm going to go over here to what might be about negative 3.2. So I know it's before this x value of negative 3.9. And I'm going to go up to about, there's 10, that's 20. So halfway between, I know that's 15. So I can kind of estimate there, right? So 10, 11, 12, 13. And that's good enough. Negative 3.2, 13. Then I'm going to do it again. Second trace max. And go over here and find the one on the right. Notice I'm on the left side of the maximum point, so I'm going to hit enter. Arrow over till I'm on the right side, hit enter. And then just hit enter one more time. So 1.2 and 13. So 1.2 and 13. So I've got almost all my critical points. I have one left to find, and that's my minimum. So I'm going to press second, trace, and then go down to minimum. And I have to do similar to how I did with the maximum. If that's my minimum point, you cannot just copy that number down. You need to move your cursor to the left, hit enter, to the right, and hit enter, and enter one more time. And we actually get negative 1. Anytime you get like negative 9 repeating, just go ahead and round that to 1. So that would be negative 1, negative 12. So negative 1, negative 12, right about there. And I know that it went down forever because I had a negative leading coefficient. You can see it on our graph. So I'm going to continue and connect these points. Doesn't have to be a perfect graph as long as you do have all the correct coordinates. So I'm going to make sure I can see these values here since we have to use them to state our intervals. And now we're ready to get started. So the first thing you're asked to find is a relative max or min, and remember to state that as y at x. So for the max here on the left, you would need to state 13 at negative 3.2. And you have one that is 13 at 1.2. So we have two relative max points, so state both. Next, for relative min, again, we're going to state y at x, so negative 12 at negative 1. So remember, y at your x value. Next, we're going to do intervals of increase. So I'm going to pick a highlighter, and if you want a highlighter for your test tomorrow, feel free to get one. Note that it increases here, and then it also increases here. So recall one thing that could help you is, I'll go ahead and fill this in, to put negative infinity on your left arrow and positive infinity on your right. And I said also to circle all of these x values so they're very prominent so that when you write your intervals you don't accidentally pick the y value instead. That would be incorrect. So make sure you circle those x's. That'll help you. So when I'm writing my intervals of increase here, I can see that it increases from left to right, from negative infinity to negative 3.2. Negative infinity to negative 3.2, close parentheses. All intervals should be in parentheses. So if you're having trouble deciding what's increasing and decreasing, I told my students to remember to think like you're riding a roller coaster, and you're always starting on the leftmost arrow. So if you're riding this roller coaster from left to right, you're going to increase, then decrease, then increase, then decrease. So again, our increasing intervals are from negative infinity to negative 3.2, and also from negative 1 up to 1.2. And notice you don't write the word and, you put the little interval symbol there. So to help make it clear, I'm going to highlight these increasing areas and highlight intervals of increase so you'll know what that matches up to. For intervals of decrease, it goes down from left to right, from here to here, and then down from here to infinity. So I'm going to highlight that purple. and write our interval. So again, always starting with the leftmost point. One thing you might want to evaluate is always make sure that for every interval, the smallest number is on the left and the larger number is on the right. So it decreases, looking at our x again, see how you can avoid using the wrong number when you circle them. Negative 3.2 to negative 1. Union, and then it decreases again from 1.2 to infinity. So writing that negative, positive, infinity will definitely help you because as you follow your finger, you'll know what to put in your interval. All right, next we're going to do on our graph where our function is above the y-axis, or x-axis rather. So just remember f of x greater than 0, that f of x means y, and greater than 0 means positive. So we're looking for our positive y's, which are above the x-axis. So on my highlighter, I'm going to, remember I said that you could cover up the bottom and then just look up here. So it's above from here to here and above from here to here. And it's above, so that means it doesn't matter about the increasing, decreasing part. So remember at this time we are done using our max and min values and we're actually only going to use our x-intercepts, our zeros. So starting from left to right, it's above from negative 3.9 to this x value of negative 2.2. Union, pick up my finger, and then this value was 0.2 to 1.9. And that's where it's above the x-axis. Next, for intervals where f of x is less than 0, that's below the x-axis. Remember that f of x is y and numbers less than 0 are negative. So we're looking for negative y's. So next I'm going to change colors so you'll be able to see it. So if I cover above, then this is what I'm looking for below. But remember, we actually have 1, 2, and 3. We've got 3 places where it's below. So from here to here, then it goes above, then it goes below again from here to here, then it goes above, then it goes below again from here to here. So we actually have 1, 2, 3 intervals to write. So starting from left to right, it is below from negative infinity to negative 3.9. Picking up my finger, negative 2.2 to 0.2. Picking up my finger, 1.9 to infinity. And that's all my intervals. So let me highlight that blue so you'll see what that coordinates to. And next we have end behavior. Please do not let this be hard. What I want you to do is look at the arrows on your graph, see what quadrant they are in, and determine what all the coordinates signs are for this quadrant. Since this arrow is in quadrant 3 and all coordinates are negative, negative, then we know our end behavior is negative, negative. So to write that, we would state as x approaches negative infinity, f of x approaches negative infinity. This negative, negative corresponds to the negative, negative of all coordinates, all points in this quadrant. Over here, as we're approaching positive infinity, we can see that this arrow is in quadrant 4, where our coordinates are positive, then negative. Positive x's, negative y's. And we will use this to write our end behavior. As x approaches positive infinity, f of x approaches negative infinity. All right, and that concludes that problem. So let's go ahead and look down here at this graph. To determine the minimum of a degree of a graph, what I want you to do is, I call it the trace test. Start left and count and see how many different areas you end up switching direction. So we have 1, and then it switches and goes down, so that's 2, and then it switches and goes up, so that's 3, and then it decreases, and so that's 4. So 1, 2, 3, 4. So that tells us that we have a minimum 4th degree function. So all you have to do is 1, 2, 3, 4. So I'm going to put up here trace test, so you'll remember to trace your function. 1, 2, 3, 4. To find the domain, recall that you asked, does your graph go left and right forever? Notice it doesn't appear to necessarily go left and right. It appears to go down, but it is continually going left and down and right and down. And also this is a graph of a polynomial function, and if you recall, the domain for all polynomial functions is negative to positive infinity. So remember, if you can answer the question, does it go left and right forever, then your domain is all reals. For range, you have to ask yourself, does the graph go up and down forever? This does go down forever, but it does not go up forever. So it goes down forever, approaching negative infinity, but it only goes up to about here. That's it. Well, if you look at your graph, this says 10 and that says 15. It's a little bit more than halfway, so I believe we set on 13 maybe as our max value. If you had 14, of course, that would make sense as well. And remember that when you state range, you go from your lowest y to your highest y. So our lowest y in this case is negative infinity, and our highest y is up to and including the coordinate 13. So remember, if we use a number with domain and range, we're going to use a bracket, okay? End behavior, similar to the graph before, because our endpoint here on the left was in quadrant 3 where coordinates are negative, negative. We would state that as x approaches negative infinity, f of x approaches negative infinity. Remember, these coordinate signs here correlate to the coordinates here. And on this end, again, we're in quadrant 4, so that would be positive, negative. So it's actually the same in behavior statement that we had before. As x approaches positive infinity, our y, which is our f of x, approaches negative infinity. And last, the number and types of roots. Please remember that this is a minimum fourth degree polynomial. So ax to the fourth, dot, dot, dot. And remember that the degree tells us how many solutions we have. So we know that because the degree is 4, there are 4 solutions. So we can say there are 4 zeros. But then what we ask for is the number and types of zeros. Well, if you look at your graph, you can see that here you have a real 0 and it crosses, and here you have a real 0 and it crosses. So that means we have 2 that are real. Well, you have to have 4 total. So since there are 4 total, if you subtract the number of real zeros, that leaves you with 2 complex zeros, or 2 imaginary. So you can use the word complex or imaginary. That would be fine, either way. And that concludes the back sheet of your review. Please feel free to watch any portion of our review videos you need to. Again, good luck on your test.